Evidence for the Younger Dryas Impact Hypothesis with George Howard. You are listening to Brothers of the Serpent podcast.
And welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents. This is Brothers of the Serpent podcast, and we are coming to you not live from the 10 by 10 by 10 tangent cube of science, where we are nestled amongst the dusty bones of an ancient seabed high atop the Everest Plateau. So I think we got a great show for you guys this week. It is a video show, so if you prefer, you can go to YouTube and watch it there. But we had George Howard on, and we basically asked him to give the presentation he gave at the Sedona trip on the Younger Dryas Impact Hypothesis, and he very graciously came on the show and gave the same presentation here. Of course, it's always different, but George is always great to have on. And yeah, it was a long episode, so look forward to that. And you know, I think it'll be okay to listen to, but if you want to see all the slides and the graphs and the pictures,
I think he did a good job of explaining what's going on, so it shouldn't be too bad for listening.
That's right. So I think we're just going to knock out some space weather news, and we'll go right to the interview. Spaceweather.com. Double solar flare. This is an update. Sunspot AR2993 erupted twice in quick succession on April 25th, producing an overlapping pair of M1 class solar flares. The double blast caused a minor, albeit long-lasting, radio blackout over Southeast Asia and Australia, affecting frequencies below 20 megahertz. New images from SOHO confirm that there is no CME headed for Earth as a result of these flares. And that is it for the Space Weather News articles today. So current conditions, solar wind speed is 487.7 kilometers per second, and the density is an extremely low 0.26 protons per cubic centimeter. Sunspot number is 112. And
that's got to be the lowest neutron count. No wonder I've been so tired lately.
That's right. It's the lowest. It's the lowest proton density we've ever had. And the neutron count is also the lowest one I think we've ever read. Only 6% above the space age average. So that is also dropping as solar cycle 25 ramps up. KP index right now is rated at 2, which is quiet, and the 24-hour max was also 2 at quiet. So that is your space weather news for the week. Not much happening, or there are things happening and we don't understand what they are. That's probably more accurate.
Yeah.
So yeah, we do have emails, and we still got stories backed up. But
I got some good stories.
Yeah, I've got good stories. We've got good emails. But I think for this week, we're just gonna go right into the interview with George because it's a long one. So I hope you guys enjoy this with George Howard from the Cosmic Tusk.
Welcome back, ladies and gentlemen, Brothers of the Serpent podcast, and we are joined by George Howard of the Cosmic Tusk, and very glad to have him on the show again to actually go through a slideshow that he went through at the Sedona conference we were at recently, all about the Younger Dryas Impact Hypothesis and the evidence for that hypothesis. So thank you very much, George, for coming on the show. Welcome. How you doing?
Hey, thanks a lot. Doing well, Snakes. It was great to be with you in person.
Yeah, man, it
last
was.
Week.
We had a great time.
Yeah, that was really cool.
You are George. Just for those of you out there who aren't sure, George is actually also cool in person.
Well, I got a lot more experience in person.
Yeah,
I'd rather the cool on a podcast is the question. I know
we already knew that.
Flesh.
We already knew that. So we just weren't really sure about you in person. We're like, well, let's see if this.
Good to be with y'all, digital or meet space.
Yeah, for sure. Yeah, it was a lot of fun. And your presentation that you gave was so great that we asked if you'd come on the show and give it here. So Of course, this is going to be slightly different because Kyle and I were unable to heckle you from the audience in the conference room. So here we can actually argue with everything you're saying. So it's going to be a lot more fun.
Absolutely, y'all heckle away, give me crap. Make it take even longer, but we'll get through it. And you're welcome to heckle. I'm just glad nobody had the courage to do it in the audience. I'm sure it was on people's minds, but I can't dance around the stage either.
Yeah, well, that's true.
As I was doing there, that was a lot of fun. I hope people will go to HowTube and purchase it, and maybe it'll pop up somewhere else on the internet sooner or later.
Could be. Well, it's going to be here for sure. So
at least this version. Yeah.
So give us an explanation, like a little intro here. What exactly is your presentation about? How did you get it? What are we doing?
It's a presentation that was developed by the Comet Research Group. Probably over 10 years ago. So I even looked at changing. So we updated it, and I was going to kind of update it, some of the look of it too, and could probably still stand that. But we updated it to 16.9 and changed a few things. There's still a few things that need to be modernized, some evidence that's not in there. But a lot of the evidence, since this was developed, before you can get into that evidence, you need to understand this evidence.
Okay.
So it's still current. It's still the basic story, the basic hypothesis. And a good thing about today is we can elaborate on, some of the things that have come up since.
Yes.
That are important, but they're all additive. They're not fundamentally changed. That makes it a good hypothesis, right? It means we didn't throw anything into reverse, right?
Absolutely.
Yeah. So that's what it is. And I think it went fairly smoothly last week. Hopefully it'll go well today. But again, we can, we're informal and, we'll take our time.
Yeah.
Yeah, we were also joined by Alan West at the conference, but he was remote on Zoom, and it was kind of difficult for him to hear us, like the people in the crowd, when we were asking questions and stuff. But he had a lot of really interesting things to say as well. But man, it'd be cool if I know he doesn't really go on podcasts, but maybe you could swing it someday, George. Get him out here on the Snake Bros show.
He says no problem asking, but unfortunately has said no to date. But he does do TV, and I know he was filming some TV recently.
Oh, that's good. That's good.
Yeah. And I'd forgotten he had some new slides, some of which were representations of what I'm going to give. I probably should have switched them in before the show, but what the heck? Maybe I can give those to y'all, and you can put it in the supplemental materials.
Yeah. Sure.
Yeah.
All right. Well, let's get going here. Let's hear your presentation, George. Lay it on us.
Oh my God.
Lay it on me, old boy.
Yeah. Okay. So George A. Howard, and I had to curse my company by putting them on there. But that's really my, I guess I don't have any qualifications because I'm not a PhD and I don't represent an august institution. I represent a mammoth tusk and a desktop,
a blog.
But if people hadn't heard me on the show before, my lane in all this stuff is kind of a really cool lane I like and very relevant to people who are pajama scientists like a lot of us are. And that's as the pajama scientist that got called off the bench or out of the stands to come play with the team. And I joined the papers early on, the very first paper in 2007. And have joined the critical ones since that I was involved with. So it's allowed me to be a co-author with 60, 70 PhDs around the world, which is a internet jockey's dream,
Absolutely.
Is to get to be a part of this stuff. So, and it also, a lot of them are, they're data nerds and lab geeks, and they wouldn't give such a presentation necessarily. Right. So it helps me probably help them by trying to science communicate some of this information.
Excellent.
Yeah. So evidence for an ice age impact, otherwise known as the Younger Dryas Impact and the Younger Dryas Impact Hypothesis. I'll tell you what I think, and I added this slide because it's important to me personally, is that there are a number of things that have become well-accepted mysteries. And a mystery should never be well accepted, right? But literally, they've become iconographic for being mysteries. That's what they will always be. unless people look for other explanations. And that's what we're going to discuss today. But those mysteries are what happened to America's Clovis people, which was the first widespread indigenous culture in the U.S. And of course, there's a lot of speculation about, and surely were previous peoples, but there's no doubt in anyone's mind that the first widespread modern, if you will, Indian culture that kind of kicks things off in North and South America were the Clovis people. And there's a lot of talk about their life ways and their hunting skills and how long they were here and where did they come from, and a lot less about what the hell happened to them.
Yeah.
Because if some of the accepted theories about how they operated when they were here, such as driving over 200 species of animals to extinction, if that's accepted, then it certainly seems like they were successful people. But their technology ended right around 12,800 years ago, which is the key time for all of this. So what happened to the Clovis people? And then what happened to all those cool giant mammals, the giant ground sloth, the mammoth, the mastodon, the saber-toothed tiger, the American camel, the American lion, the short-faced bear? You literally could go on and on and on and on over these amazing animals, some of which have just analogs today, or analogous animals. There is no woolly mammoth anymore. They're completely gone. They're still elephants, but what in the world happened to their cousin, the mammoth, and all the other species? What caused the flood? You could say floods, and I mean both mythical and actual, that hundreds of cultures report a tremendous catastrophe and floods and turmoil in deep human time. And of course, that's all questioned. But then there's actual evidence for large-scale floods around this time. And, really kind of the most important when you get right down to it, and it might sound a little self-serving to someone who helped propose the theory, but I think it's the most important damn thing ever discovered in human history.
Yeah.
And that's because why did we change so dramatically in the last 13,000 years? You've had anatomically modern humans now have been pushed back to 300,000 years. So that's 287,000 years where we just sat around doing nothing more than making tools and painting on some cave walls now and then. And then after 13,000 years, we began to flourish and build civilization. Some people may think that'd be a step back, but there's no question.
Yeah, agriculture, architecture, and astronomy.
Yeah,
exactly.
Boom. All came following the event that we're going to talk about today. And sometimes I put it, we went from plucking pears to pulling plows.
Yeah.
Right. Our whole approach to the earth changed for better or worse. I think it's a transitional phase. I think it was a necessary phase. Maybe we can chat about that too. But there's no question that modern humans can kind of date their cultural origins back to this event. And I think it's responsible for the naked ape and the black mirror. That's why we are the technological beasts that we are.
So before you move on from this slide, what you mean by well-accepted mysteries is that in scientific thinking, these four mysteries are sort of like they've been set in as like, yes, these are big questions and they don't really have good answers. Is that what you mean? That like,
I do. And it doesn't seem like they expect a good answer.
Right.
Let's take the extinctions as a great example. You've got the three, and I'd argue now 4 predominant theories. And if they would research the fourth, which is the extraterrestrial impact, nearly as much as they have researched the first 2, climate change and human overhunting, I think we would have proven this by now. Okay. There are more grants in 6 months on even those obscure subjects than the Younger Dryas team has received in its entire lifetime. Right. So we've kind of accepted the mysteries, and we don't go push with the new idea and see whether the new idea could be proven or disproven. Mm-hmm. It often by the mainstream just gets ridiculed. At least the public face the mainstream. I think behind closed doors, they're very interested in what we're doing. So we've kind of accepted that these things will never really be answered. And we think we've got a hell of a good answer.
And so before we move on, going back to the Clovis people, I've always wanted to ask you, what do you think about the fact that we find their habitation sites and their tools, but we don't find them? Is that part of the mystery? Do you think that, like, you know, but that we find their tools, but there isn't really, except for the one, what is it?
The Montana child.
Yeah.
I believe.
Which is not it's not even really in the right date range to be.
That's right.
You know, so it's
Anzac one.
Anzac, yes. The
Anzac
Anzac skeleton seems to have been buried amongst maybe Clovis artifacts, but really they didn't get to check all that until after all that stuff was removed, right? So it's from the cave. So I
won't say it's inexplicable. If I said it was inexplicable, I'd be accepting a mystery like they accept it, right?
Right.
So,
but where are they?
It certainly is explicable. But God knows how in the world can someone populate from Seattle to Miami to Tierra del Fuego in 200 or 300 years and have that kind of footprint and not leave any skeletons? I do not have the answer.
Yeah. So to us, we've talked about this before. Is it possible? And I know you don't have the answers to this, but is it possible that some skeletons have just been misattributed to other people's? In other words, we do have Clovis skeletons, and they just haven't been correctly. I don't know. It's strange.
Well, I think they throw out as many dates as they accept. I've heard, from people that are in the labs, and I think a lot of things, within 2,000 or 3,000 years, like that could be missed. There's also a Texas skeleton that's pretty obscure called Brazoria woman. Look that one up one day.
Okay. Watch her.
She was found bound, if I remember correctly, with face down.
Oh,
and, and the marshes associated with I guess it's the Brazoria River's terminus there in the Gulf or something. But BLM found it and they dug her up and then I think put her back.
Yeah,
and it didn't get intensively studied, but there's certainly a pretty detailed BLM report on it. But you certainly would think you'd find more than a couple of skeletons given their geographic spread.
Exactly. All right. Yeah. Thanks for that. Let's keep moving forward here.
And the mystery of how we came out of the, kind of similar a little bit, is how we came out of the Younger Dryas so suddenly.
That's right. Yep.
The beginning is studied a lot and the end is every bit as mysterious. So let's kind of outline the hypothesis, and that's that a ET impact event occurred approximately 12,900 years ago. I'm kind of, partial to 12,887 around June 30th, right? But we hadn't zeroed it in that far.
What time?
You can actually...
Come on.
9 o'clock.
9 p.m.
I hope it woke them up instead of the, I'd rather something like that happen in the beginning of the day rather than ruin a good day.
Oh, okay.
Right? Yeah. They do have it to June or at least the summer through the Lake Varbs in Germany.
Wow.
And I don't think they call the year and say unquestionably it's 88 and 87 or 86. I forget how they deal with that, but there's some fluctuation there. But the fact it happened in June is actually been noted or speculated based on evidence from lake vars, which are the accumulation of lake sediment over a long time. And they change each year it changes, so you can see what time of year laid that var apparently. So we believe it would have the nature of it would have been thousands of air bursts across the northern and southern hemisphere, and that's when objects up to I think roughly 100 meters or so, which would be the vast majority number of what came in, doesn't make it to the ground per se, but blows up pretty much just like a nuclear bomb, but without the radiation. You get the intense heat, you get the shock wave. All of that occurs, but you don't leave any radioactive fallout. You do leave some fallout, and we're going to discuss that. And that's the debris that you find across 4 continents that we call the Younger Dryas boundary layer. And most of that is microscopic to very small, but it's the same kind of indicators that were found that ultimately proved the comet dinosaur extinction. All right, so you're using those exact same approaches. And then cubic kilometers of meltwater were released. Where they went, We know Randall speculates in the scab lands, and certainly there was activity up there. And the mainstream believes that it was the Mackenzie River in Alaska these days, although there have been a lot of arguments about that too, or not arguments, but a lot of investigation and contrary opinions, I guess. But the Lake Agassiz was released, and it went somewhere. And I'd say the majority bet these days is the Mackenzie River Delta. And all of that meltwater halted the North Atlantic Ocean circulation, otherwise known as the Gulf Stream. And you got to remember that's well accepted, right? And there's kind of an area where the Younger Dryas event picks up amazing things that are well accepted, like that the Gulf Stream halted. But it also applies to the ET impact hypothesis, and in fact, it helps answer, because if you ask mainstream, what caused the Younger Dryas, they'd say, well, the Gulf Stream stopped. You say, what caused the Gulf Stream stop? And they'd say, well, a bunch of fresh water came in. You'd say, where did the fresh water come in? Came from the lake. Well, why the hell did the lake suddenly release into the North Atlantic? And they'd go, we'll know, right?
Right.
So we're pushing that back one step and saying we think we have a cause for that meltwater release. And that all of that initiated the Younger Dryas cooling, which probably a lot of your listeners know about, but that was a 1,200-year period from 12.8 to 11.6 thousand years before present, where northern hemisphere temperatures dropped up to 20 degrees Fahrenheit. God. And virtually instantly. As far as we can tell, it was instantly. And then we believe all of this turmoil contributed to the megafauna extinction, which surrounds that time. And we'll talk a little bit more about it, but is most intense at that time. And a lot of people will think that what we've proposed, and I've seen it before, is that this happened and vaporized all these animals instantly. Well, that doesn't make common sense. It certainly didn't vaporize all of us instantly. Some survived, but there was an ecological collapse and a habitat loss factor, particularly in North America, where we believe it was concentrated, that would have led to extinctions of big mammals that no longer had their food sources. And we believe it triggered the collapse of that first American indigenous culture, the Clovis people. So that's the hypothesis in thumbnail. So let's talk about the evidence. What do we have that supports this? We've got 40 plus sites in 12 countries on 4 continents. And that ranges from California to Germany, and actually when I say that, I should probably add it to the slide, but to Syria and Chile as well these days. And more than 25% of the Northern Hemisphere. And a key thing is that we found no boundaries yet, fellas, right? We operate on very little funding. And substitute that with great time and hard work. But over the last, what's it been now, 15 years, any site that we have tested that's been suitable and proper and in a grading environment where you're gathering steadily sedimentation over time, when you go to the places that are 13,000 years old, we haven't found a place yet that doesn't exhibit this evidence.
So I know we haven't gotten into the specifics of the evidence yet, but if there's spikes of like iridium and what was the other platinum group metals in all these sites, you would expect if there was like a single impact event somewhere, right, that those spikes would level off like the further away you got from that zone. So do you think that the fact that there's no boundaries found yet, that there was a bombardment event that may have like been global? So it was lasting long enough for where things were coming in all over the entire planet?
Yes, I do. And that stands to reason, with regard to how meteor showers work. They'll be intense. Most intense during a particular night, but they'll wane and wax before that night, that you'll have a curve. And I'm not an expert in it, but I know plenty that are. And this could have gone on for 2 or 3 days.
Right.
Right.
Okay.
Or it also could have been 2 or 3 hours. We saw that with Shoemaker Levy 9. I forget how long it took that fragmenting comet to have all the pieces interact, but it wasn't instantly. And I think it was over a day or two.
Yeah. So it's
I
like
could certainly be wrong
like
about that. Yeah.
passing through the tail. The Earth is spinning multiple times as it goes through this cloudy tail, and it's just getting hit on every side, every part.
And it's going through a particularly rough part of that tail.
Yeah.
And we'll discuss it a little deeper in, but that this comet was probably fragmenting for up to 7,000 years, we estimate, before we hit that part of the tail. And it's still fragmenting, and that's known as the Taurid meteor stream. If we're correct about this, it could have been something else, but there's been a fair bit of math and kind of reverse engineering done that suggests it was the Taurids, and that's the most likely culprit. And as we say, that's end of June, early July, end of October, early November.
That's right. So the June Varv date that's why that's interesting, right? And the June crossing is the sunward facing crossing, right? So it would have come out of the morning sky. Is that the idea?
That's right. And you wouldn't have been able to see it coming.
Yeah, that's right.
Yeah. Yeah. You can see the I guess they call them the beta taurids or whatnot, but you can see the second taurid interaction there in the fall is visible to us.
Right. Because it's the night side, right, away from the sun.
Right.
Yeah. Okay.
So there's a particular, I call it a hack, but it certainly doesn't have anything to do with computers, more just like a way to get the most out of something with available resources. And the hack of the Younger Dryas team, Comet Research Group, as we call ourselves, is to go to well-dated archaeological and paleontological sites that have already been very well published and accepted by the mainstream. So paleo sites have been studied for 70, 80 years in the U.S. and been studied with using dating techniques for 50 or 60 years, using carbon-14. And those are well established in the literature. And within the stratigraphy, within the accumulating sediment on the site, they know the dates versus the depth. So if you go to those sites, then we don't have to argue about the dates.
Right. You don't have to establish that, this is at
That's right.
12,600 or whatever.
That's right. And the trick is to gain access to them, and given our credentials and charm, we have gained access to those sites. And you go and you sample up and down the face, and we'll talk about that a little bit more. And you find evidence at the 13,000 time period for kind of the breath of hell having encountered North America at that time. So you'll find the abundance of the evidence at that level. And we know that level is 13,000 years ago. So you don't have to argue about the dates, although certainly we've done some dating, but it helps establish it because those sites are already established. So the very first one was up in Gainey, Michigan. And that was a fellow named William Topping, who then contacted Dr. Richard Firestone at Lawrence Berkeley Laboratory out in San Francisco, who added a hell of a lot of credibility to it. And then it moved on a few years later, the hypothesis, to our team, the modern iteration of it. I was in touch with them in 2001 when they first published that. And then by 2007, we had published a paper that included Dr. Firestone and 22 others and myself. So it started Gainey and some of the other sites. There's Shabbat in Canada, then Wally's Beach in Alberta, Manitoba, Daisy Cave in Arlington Springs out in California.
Now, are these second? Are these all Clovis sites? Okay.
Yeah, that's right.
So they're well established. Like you were saying, they're well established Clovis sites with known stratigraphy, and you guys people were looking for the Younger Dryas proxy indicators at these sites that already had dates for all the layers. That's the goal.
Exactly.
Okay.
Exactly. Very effective way to go about it, rather than trying to find an entirely new site, for instance.
Yes. Yeah. Okay.
you run into the same thing. There are a lot of really good folks out there that contact us all the time and think I found the black mat. I found the layer that we're going to talk about in a little while. But the problem is they generally hadn't dated it yet. Right.
Right. Yeah.
So if you start up a new site that someone has found cold or suspects, and that's happened, it's happened up in Pennsylvania and it's underway now in Louisiana, actually, we are going to have to redate the site. And that takes a fair amount of time and expense.
Yeah. Okay.
But these were all established sites. So Murray Springs and Leonard there in Arizona. And along with Murray Springs, another iconic site that just shows the black mat perfectly is Blackwater Draw in New Mexico, which was the type site for the Clovis Point. That was where the first Clovis points were located. And then the Topper site, and Al Goodyear, who is the dig director there, longtime dig director there, and a wonderful, wonderful human being. His site in South Carolina that is controversial actually for its pre-Clovis indications, that he believes some of the lithics and human evidence found there reaches back up to 50,000 years, but we find this evidence at Topper at the 13,000 year level. And then early on in the first paper, the Carolina Bays were included. And y'all might have heard me refer to them as the kooky caboose of the theory.
That's right.
It's always going to be a part of it, but we got to kind of keep her in back because it's just not the best evidence, because the dating there can be really squirrely.
Yeah.
Okay. And that can have explanations related to the event itself, but it's just such a controversy within itself. The Carolina Bay evidence doesn't make it into the kind of the modern presentation of the site evidence. So I know that most of your listeners aren't viewing, and I need to be cognizant of that, but we're showing a little slide now of how it reached over into Germany and Belgium and the Netherlands. And that's a wonderful exhibition, if you will, presentation of the black mat. And those are found in the Northern European cover sands, as you call them, which are fairly deep sands, windblown sands that I guess accumulate there over certainly millennia. And if you go down about 2 or 3 meters in the Netherlands, shows it best at a site outside of a town called Usselo, you'll see that black band. And you'll also see that the soil or the sands are generally colored differently below it than above it. And you'll see that in the US too, which is indicative to me that, not only did something happen there, but it just changed the way the world was at that point. Because the soil, it changed everything. Because the soil, even if just a slight shade different, you're like, why in the world would it accumulate for 10,000 years before and have this one shade, and then the last 13,000 years it has another shade?
So you can have all these megafauna that die out and all the species that die out. Maybe there were some plant species as well that died out.
Yeah.
And then afterwards, of course, all these other animals that may have been not very prominent could have risen to prominence because the other animals were now gone. And then that changes the whole biome, changes the type of pollens that are in the air. And I don't know. That's just
It was another world, man.
Yeah.
It changed the world. And again, back to the area between mainstream beliefs, which accept a lot of this, and then where we add to it, I wouldn't say we depart, that we divide the geological ages at that time. That's the transition between the Pleistocene, or Pleistocene as we call it, and the Holocene that we live in now. So that's been accepted for, I don't know, a couple hundred years. I'm not sure where they define the terms and all of that officially, but no one disputes that the world changed very dramatically 13,000 years ago. And then you're reaching back 2 or 3 million years of Pleistocene. So think about how recently it suggests anyway. Those ages are multiple millions of years each. But the recent change was only 13,000 years ago.
Right.
That's a fraction of a million years and a smaller fraction of several million years.
Yes.
So, and I could get into this. It gets kind of philosophical in a way, and I don't know, more mathematical than I'm probably qualified to say. But I believe the fact that it happened so recently, which leaves many scientists believe, well, certainly we didn't have a dramatic impact this recently because it's just too recent.
Yeah.
Well, first of all, that's not true. You can always roll double sixes. You can always, an amazing thing can happen at any point. But I believe that we're here to see the catastrophe so recently because we're a result of the catastrophe.
Yeah, that is an awesome philosophical concept, that the catastrophe caused the change in the way that humans lived all over the world, which resulted in our technological civilization that can now look back at the event that caused us to be here.
Therefore, it makes sense that it wasn't that long ago.
Yeah, it is really.
And it's like your grandfather is mysteriously murdered, and somehow that leads you to become a detective, and then you discover who killed him.
Yeah, there you go.
But if he hadn't been killed, you wouldn't have become a detective.
Right.
Right?
Yep. And before we move on from this, your slide here is demonstrating the distance, right? It's saying 4,200 miles from the Topper site, which is, where's the Topper site? Is it
in South Carolina?
I believe it's Topper. Yeah.
Okay. Yeah. Yep. So that's a long spread for for these indicators to be, and that's showing that it's covering a large part of the northern hemisphere at least.
Yeah, and particularly as abundant as they are there. The black mat goes for miles and miles up there.
Ah, okay, yeah.
Yeah, and Chris Oy, who's from the Netherlands, who was there, he was just pleased as punch, out in the audience when he looked over my show. He saw me work on my slideshow.
Yeah.
And he goes, "There's evidence in the Netherlands?"
That's right.
And I was like, "Oh my God, there's great evidence." And he immediately Googled it. Great guy. He just contacted me today, tell me the trip would wound up, what a good time he had. And said that the field trips were awesome this week.
Cool.
So lucky guy, I got to go on the field.
He was one of the many great people I met on that trip. I tell you, I really enjoyed last weekend.
Yeah, it was a lot of fun.
A lot of great people.
All right, well, before we move on from this slide, let's go ahead and take a break.
Yes, sir.
And we will come back with more of this excellent Younger Dryas Impact Hypothesis presentation by George Howard. And we are back, ladies and gentlemen, Brothers of the Serpent podcast. This is the second hour, and we are joined by George Howard, who is giving us a presentation on the Younger Dryas Impact Hypothesis that he gave last weekend from where we're recording now at a Sedona conference. And it was such a great presentation that we asked him to come on the show and give it, and that's what he's doing. We're moving our way through the slides. So where are we going next, George?
Well, we just kind of showed and discussed where the fallout, if you will, came from. We're going to talk about it a little bit more, what the fallout looked like from this event and where it's found and how you can see it in your own backyard if we knew the date was correct. Because theoretically, any place that has had an aggrading environment, aggrading means it's constantly adding sediment in a regular fashion over time. And those places aren't everywhere, but they're not super, super rare either. You should be able to dig and show a stratigraphic face, and depending on where it is, and again, the conditions immediately after the catastrophe, it may exhibit a black map, like at Murray Springs, Arizona. And that's what our slide is showing here. And I'd say for our purposes, that is the iconic location demonstrating the effect of the catastrophe. And like we talked about not long ago, see how the sediment is one color below for presumably thousands of years below the black line. And what we're looking at here, folks, is a distinctly changed disconformity in the sediment's kind of color and character. And it's kind of a chalky white, light gray, and then it goes black for about, I don't know, what is that, 3 or 4 inches?
Something like that, yep.
And then it's never the same again.
Right.
Then it grades from a lighter color, black, gray, up to another color, and then seems to be more of a kind of a rusty type color. So something changed very dramatically right there. We had some discussion of this at the conference, that you can find black mats and repeated black mats in some strata. And we're not saying every black mat is the indication of a catastrophe, because here's an important distinction that is justifiably missed by some folks, even if they're very interested in this and have learned up on it, but generally got to be, have this pointed out to you. The black mat and the Younger Dryas boundary layer, although somewhat interchangeable, and I've even, messed that up, particularly if people don't know about this distinction, are two different things. Okay. That the black mat is the ecological detritus of the wasteland. There's a lot of talk about the wasteland and what an interesting term that's used throughout mythology at various locations to describe times when everything just went to hell. You call it the wasteland. Well, this was the wasteland, and that wasteland would have been of a much colder, wetter, and highly algal nature, certainly out west. Because you went from a dry, arid condition, and then you had algae and wetter, colder veg growing, and as that accumulated, that's what created the black mat. The Younger Dryas boundary layer, on the other hand, is in immediate contact with it just below it and is not necessarily visible. The Younger Dryas boundary, where the evidence is found, that is not necessarily in and of itself going to be visible to the eye. And you can see that at Topper. At places it is and places it is in it, you'll find the peak of the materials we're going to discuss, but those materials aren't visible to the eye, but their effect on the ecology is, and that effect on the ecology shows itself as a band of black soil. So there's also, go ahead.
The area that we live is not usually, we're on a plateau, so it's erosional rather than depositional. There is a place here somewhere where they've found the Hall's Cave, where they've found, I don't know if it's black mat, but they found the boundary. They found the boundary.
It's visible.
Okay, it is visible there.
And that's microstratigraphy.
Yeah.
Hall's Cave, I think the whole, 20,000 years, I don't think it's just but like a meter or two.
Right.
Wow.
At most.
So what I'm thinking right now, actually, is that there's a couple of places I'm thinking of right now where I know there would be it's a cave and it would deposit in there. And I wonder if we could dig down and find black mat.
That'd be cool as hell.
Yeah.
That'd be really cool.
Also at the conference, Alan West said that the black mat above the Younger Dryas boundary in some cases was deposited over like the following 300 to 600 years or something. Didn't he say that?
Yeah, 2 to 3 sticks out in my head. But
300
it took
years
a long damn time.
Yeah.
Yeah. Of wasteland.
Yeah, 300 years of wasteland deposition that created that black layer. That just blew my mind.
Yeah, if people hadn't seen it and maybe hearing this for the first time or hadn't seen the black mat, it's pretty easily Googleable. Younger Dryas black mat. And there in Europe, you call it the Ussello horizon, USSELLO. So what do you find? What's important about the black mat? And this was known by archaeologists and paleontologists kind of more as colloquially and within their circles. And I'm not sure how much it was published as a distinct protocol, but they've known for years that if you have a distinct black mat around this time, that's when you start finding the artifacts and the bones and remains of the animals. So you find the people and you find the extinct mammals below the black mat and never above it.
Okay.
And that's entirely analogous to the KT boundary, the Cretaceous Tertiary boundary, 65 million years ago, where it's been well accepted using very similar evidence that the dinosaurs extinction was caused by a comet. But that, and this is important too, that has turned into rock. So that, it's called a black mat, or they call it the KT boundary. It's visible too, oftentimes as a layer of clay, et cetera. But you don't find any, obviously human, but you don't find any dinosaur remains above that. And what they knew, I guess I started rambling off there, but what they knew when you're digging at these sites is that when you get to the black mat, that's when you're going to start finding the interesting things that they're after, including Clovis artifacts and the impact proxies, as we call them, because you're not going to find a video of the impact. You've got to have some kind of interpolated, inferred evidence of it that's a proxy for what happened. And that is summarized by magnetic spherules, platinum and iridium, and nanodiamonds. And we're going to talk some more about those.
Surely
Those
someone
all
recorded
peek
the
into
impact in a crystal skull somewhere.
That's right.
We're just not looking for it, right? If we were looking for primary evidence, we'd probably find it. They certainly built some temples that suggest that date, doesn't it?
Yeah, they did.
That's all about it's about as close to a video as you could get. Okay, so kind of playing on that same theme, but here's a great example. You'll see that cursor crossing across the screen right at the black mat in the back of that excavation site at Murray Springs. And this is probably in the late 60s here where they're digging. So you find the black mat at 12.9. And then what do you find directly below it with its bones stained black by the mat itself is Eloise the Mammoth, they named it at the site. You find an articulated mammoth skeleton that was immediately after death in contact with the mat itself and the destruction layer. So why do I say immediately and not that it killed it? It's because this is a butchered animal, right? That it was found in association with Clovis points that have been used to kill it and butcher it. So it was killed by man. And I doubt they had time to experience the fallout, kill a mammoth, start to butcher him at the same time.
Right.
So it was clearly just before it. And how do we know it was just before it, not sitting around for months and months, is because that's that articulated part of the description of the skeleton. Articulated skeleton means that it's still relatively intact and all the leg bone still connected to the thigh bone and the elbow, bone is connected to the arm bone and whatnot, that it hasn't been dragged off by scavenger animals or distributed around by the hunters themselves. It's still laying there in a state to be butchered. And then it's immediately covered by the black mat. So that suggests that within a period of days, the mammoth was killed, was being butchered or whatnot. And then the catastrophe happened, which is fascinating. And again,
Alan West was talking about this as well, and he says that or at least when he was talking about it, he said that the two rear legs had been removed and taken to a different area. So it's really interesting because all that stuff you just said. So it implies that the Clovis hunters managed to kill this animal. And they were in the process of taking it apart. They had removed the rear legs and taken them to a camp somewhere. He said it was over the ridge, presumably for continued butchering and eating it. And the mammoth was still there. And the Clovis hunters did not return to complete the butchering of the animal because and like you said, it's still articulated. The black mat itself and the Clovis boundary, or the YDB boundary, is right on the bones. And it wasn't taken apart by scavengers.
That's right.
So that implies that the scavengers couldn't get to it either, or they were all having big problems. So both the Clovis people and any scavengers that would have taken this animal apart did not show up ever, and it just got completely buried. Really interesting.
Isn't it cool? And
so it's surprising that they didn't find any Clovis people skeletons in any of this stuff.
Right.
Where did they go?
Yeah.
I don't know.
Man, it's just a great question. Just a great question, particularly if there was a catastrophe. There would have been someone on that campsite.
Right. Where's the Clovis person with the black mat laying on top of them?
Yeah.
It's strange. Yeah.
And that devil's advocate could say that causes problems for our theory, I suppose. But if they are never found anywhere, everybody's got the same problem.
That's right. It's everybody's problem, not just the YDB problem.
Hypothesis.
Yeah.
That's right. So again, in situ, which means, at the place where they were, last utilized, you don't find, or last walking, there's no in situ bones or Clovis artifacts in the mat or above the mat at the 50 sites that we've looked at. The impact markers cover the bones just below the mat. So you got the bones, you got the YDB layer with the impact markers, and then you have the mat above it.
Again, so
And,
Dr. West said that under the bones, there were no proxies.
Yeah.
But on top of the bones, there are. So that's a really good indication that it was laid down on the ground there before the impact happened, and then the impact happened, or whatever. The event took place after it was already laying on the ground, because you find the proxies on the bones, but not under them. Really interesting.
That's right.
Yep.
That's right. And some of your listeners are probably like, hell, that happened a few weeks ago. I saw something just like that. And indeed, entirely similar circumstances were discovered in the dinosaur site. I believe they call it Tanis or Talus. And isn't it Montana?
Watcher.
But it was, yeah. Oh, can I use the Watcher?
You can.
Watcher. Yes. What do they call that site? And then is it Wyoming or Montana? But that site was revealed a couple of years ago as suspected to show real time interactions of dinosaur bones and remains with the bad day itself.
Right. The actual impact.
Now they have zeroed it down. Yeah, they thought it was really close, and they found like fish, I believe, that had inhaled sediment-laden waters, and it was in a turbulent matrix and whatnot. But now they've revealed that there's, I think it's a dinosaur leg bone.
Yeah.
That was directly covered by the black mat, and their claim is, just as ours, that would have been, that would have been something that witnessed the impact itself. Because, if you find something an inch below, that could be a couple of 100 years. All right. It's only right when it's covered by it could you claim that it experienced the event itself while still fresh. And in the case of that other impact, in the dinosaur impact, that would have, that probably was what killed that animal. Here, you don't claim that that's what killed it because it was already being butchered.
And yes, it was Tanis in Montana.
Yeah, Tanis in Montana. Good. Not Talus in Wyoming. Yeah. Okay. So moving on. It's kind of cool because anybody could do this. It's just hard to take the second, third, fourth, and fifth steps. But the first step of doing this kind of investigation.
North Dakota. Tanis fossil site.
Oh, is
Dakota.
it? Shit. Way off.
It's all right.
But why are they?
That's okay.
Watcher got it. Tanis fossil site.
Yeah, I was
North
looking
Dakota.
at a map, and they show you. It says Montana and Wyoming, but yeah, there's North Dakota, South Dakota. There's like a whole.
That impact bores me anyway. I mean, 65 million years ago. It just might as well be on another planet.
It was another planet, yeah, for sure.
Yeah. And 13,000 years ago is 1/5,000th of that.
That's
All
right.
right. So this is 5,000 times more recently. And people can be forgiven, but usually when you're talking any kind of things a long time ago, it all blurs into hell. It was a long time ago.
Right.
But you just do the math. And 13,000 years ago is a hell of a lot more recent than 65 million years ago. And think of in terms of a timeline reaching here from North Carolina out to California. It would have been a few blocks away from a timeline standpoint if the impact were in Barstow, California on I-40, which goes all the way to the West Coast. So just a few blocks, not even a mile, because we're not 5,000 miles from Barstow. So
Right.
that's a lot of intervening time.
If the dinosaur impact was from your office to California, then the YD impact would be over to the gas station nearby. I think that's what you said at the
Precisely.
Yeah.
Precisely.
Right.
Yeah. Yeah. So that's, it's fun to think about. And
Yeah.
again, it almost makes you think, it's strange that we'd be so closely related in time, but maybe we are the result of that impact or our ability to detect it. And had it not happened, we'd still be hunter-gatherers and cave painters.
Right. So what are we looking at here? You've got somebody's holding a bag full of
a
sediment.
neodymium magnet inside of a Ziploc bag.
Okay.
And neodymium magnets used to be really, really expensive, but you can get them cheaply now off of Amazon. And they're super powerful, not something you want to get near your belt buckle or your phone or your credit cards or anything like that. And they can, if you have two of them, it can snap you really bad. But that powerful magnet, if you pass it along the stratigraphic face, of a dig site, it's going to draw from the sediment the magnetic fraction, as you call, all those things that have some iron in them, all those little bits. And a lot of that's just going to be little bits of iron enriched sediment in one way or another. But it's also going to pick up the little bits that were the result of the impact itself. And you call those magnetic grains and spherules.
Okay.
It wouldn't pick up the silicate spherules. You'd get that with iron, but we also find silicate spherules. So that's kind of the first step to get the material. And then you take that material and further sort it down and down and down. And then you go through a very, very tedious process with very expensive transmission electron microscopes to look at the nature of those little bits. We call them magnetic spherules oftentimes. And what I'm showing now is some close-ups, if you will, very close-ups, and they'll be smaller than a speck of dust. And then there's another class of them that's, much smaller than a speck of dust. But what's happening there is when you get the column of hell coming from an air burst or an actual crater forming event, there well could have been some of those too. But when you get that high heat environment, you're going to actually melt the surface material, mix it to some degree with the impactor material itself. You can also have these little spherules ablate from the incoming object itself, where it would be purely made of that material. But that material, the magnetic stuff and whatever else is involved, kicks into the air into a vapor. So it's liquefied to some degree, to a great degree. And then it essentially freezes. And when it freezes back in, just like a hailstone or any other kind of thing that goes from a liquid form, out in the atmosphere into a frozen form, it creates spherules, right? They perfectly round little balls. And those are well accepted part of the dinosaur impact as well, and other impacts around the country. So this is not around the world. This is not a line of evidence we made up, although it'd probably be worth it if you're the first person to discover this. You would definitely seen evidence and could have speculated that this is what caused it. But this is based off of years of confirmations that impacts are associated with spherules. And that runs through the entire KT discussion.
Right. So just going back, spherules themselves are evidence of vaporized metal in the atmosphere freezing into little tiny spheres. And when you have a thick layer of them, then that is a proxy evidence for a high temperature event like an impact, right?
Very high temperature, because they'll find molten material in it that would have had to experience, 5,000, 6,000 degrees Fahrenheit.
Yeah.
Enough to melt a car into just a pool of undifferentiated material in, less than a minute.
Right.
Right. And then you kick all that stuff up because you've got the shock wave as well. It's all separated, and then it's fall out and rains back down and shows these spherules. So there's one selection of a great paper that Malcolm Lecomte led in 2013, where someone had called into question the spherule evidence based off of very, very little field work. And then they went back out there, went all through it again, found new materials, and proved it even better than it had been proved in 2007, that these spherules were abundant at that layer and did not, or were much diminished above and below it.
Okay.
Then you have another class of stuff called carbon spherules. And that's the molten carbon. You would have had obviously vegetation and animal and biota of various kinds, and that would have all gotten whipped up into this. And some of that also falls down as these carbon spherules, and they're fairly large, 3 to 4 millimeters. But they've got this dynamic interior that suggests that it was molten because they're glass vesicles inside it, where you got little thin walls where the gas
was trapped.
Gas kind of trapped and wasted away, or at least it reformed in an irregular fashion around pockets of gas. And there's a little more of that.
Oh, yeah.
Those are found in abundance as well. And then you got some bigger chunks. That's glass-like carbon, GLC. And that's where it didn't make it to the full vaporization, just like you'll see. I don't have my meteorites here. They're at home, but I've got some too that have that same look, even though those are iron. This is actually carbon that is molten in that inferno, that 5,000 Fahrenheit inferno. And some of those pieces actually form into larger conglomerations, and you call that glass-like carbon, and those are indications of intense firestorms. So you got a lot of surprising things in that layer, and we've been through a few of them, but really the most surprising was trillions and trillions of nanodiamonds. And nanodiamonds are not formed, not found in nature outside of impacts. So that was excellent evidence. And it came up right at the end of when we were about to publish the 2007 paper, if I remember correctly, and then was added to it. And maybe there was a site or two where they had defined them, and they went on to find them at sites around the world in abundance, including the Greenland ice sheet, where there's actually the ice changes color. There's a wonderful NOVA they did on our research in 2009 that was later forced off of streaming by our critics.
Oh my gosh.
Oh yeah. They did a whole NOVA, the Cadillac of TV, right?
Jeez.
And I was so excited about that because as a civilian, most of the PhDs and stuff, they ain't in it for TV, but my mom called me the TV kid. It ain't real till it's on TV. So I was excited when that came out, and that didn't last long because by 2011, through some non-public process, the critics of the hypothesis, particularly after the first critical papers that were quite thin and later well rebutted, came out and said, we've proven these guys are wrong and they're frauds, and you need to take down your $1 million episode of Nova.
Oh, man.
Yeah, and it lives on. You might want to add that to the show notes if you could.
I'd love to. Send me the link and I'll put it in there. Yeah.
Yeah. Mark Young's YouTube site, Incendix, I think it is.
Yeah. Incendix. Yep.
Yeah. Incendix. He keeps it up, and if he doesn't have it up, somebody else pops it up.
Okay.
So
awesome.
We're encouraging copyright infringement, which is great.
Another day in the cube.
What would the internet be without copyright infringement?
That's right.
It's a silly place.
But they burned our book, or they burned a book about us. They just got rid of it. People aren't allowed to see the show because I guess it would be misinformation, disinformation.
Yep.
In their view. But that's so disappointing. So that's been over a decade now that's been unavailable at PBS's website. They still have remnants of they did a whole website that accompanied it. They just don't have the streaming, and you can, at least last time I looked, you can still find kind of their show notes about it, their accompanying website. And they loved it. I mean, the producers of that program and whatnot, they were all into it, but somebody got to them up at WGBH Boston, and that was a cowardly executive who said to take that down.
Yeah.
So you got trillions of nanodiamonds, and those are very, very hard to characterize. And you have to not only identify them through the electron microscope, but then to prove that they're nanodiamonds, you have to use these X-ray diffraction techniques. find their diffraction patterns, and only certain diffraction patterns are indicative of diamonds. And we've nailed that part of it. It's gone back and forth. But clearly there were nano diamonds at that layer, not above it, not below it. Some sites, they found them again throughout the column when they tested carefully. I think it's Bull Creek in Oklahoma. And then somebody, I believe it was an outside group, when that said, okay, yeah, they're there, but we find them 2 other places. Well,
yeah,
at least my version of the hypothesis says that we probably experienced lesser versions of this 2 or 3, perhaps 4 times since the 13,000 year event,
right,
that weren't as destructive, but could well have, left similar results. But generally, they're just in the column at that one place. And we found those in a bunch of sites. We'll show you how many in a moment.
So to be clear, you're the thing with the nano diamonds is, and this has fascinated me for a long time, is that number one, they're incredibly tiny. So the magnetic spherules and the carbon spherules we were just talking about, compared to these, are very large, right? These nano diamonds.
That's right.
These
thousands of times larger.
Yeah.
Thousands of times smaller. Yeah, you're down in the nanometer zone.
Right. It was, I think your previous slide said 1,000 times smaller than a bacteria or a human cell. And then what you have to do to prove they're diamonds is that they have a very specific diffraction pattern when light passes through it. But how do you do that to something that's that small? So you have to use very expensive equipment and do a tedious test, but they have proven that these are actually diamonds and not some other glassy translucent material by the diffraction pattern. That's right. Yeah.
And it intrigued us so much that Alan and I actually got a patent on how to produce them in anoxic environments at certain heat. And we were able to produce them in a lab here at NC State that we rented. And I had to, because that was a business thing, it ended up not scaling, and I had better things to do, and probably Alan did too, but we did get a patent and we did run it to ground. And we were able to produce them, relatively easy, in laboratory conditions that didn't include insane pressure.
Oh, okay.
Right? So we weren't able to create the pressure. So we think there's a little something else going on than the typical diamond formation mechanisms
of high heat, high pressure. Yeah.
High heat, high pressure. We think it has more to do with high heat and low oxygen in an anoxic environment.
Okay.
And there's some indications, and actually you can Google, I think they've produced them now with candles, and that didn't surprise us too, that they found out that diamond, the candle flames in certain conditions would create these diamonds. And again, suggesting that it wasn't necessarily high pressure that created them.
Okay.
But they are diagnostic of impacts, and for particularly crater forming events, they form them too, but that doesn't necessarily mean it was the pressure. It might have just been the heat and the oxygen environment.
Okay.
Yeah. And we found those in the carbon spherules. And that was, it's interesting. The carbon spherules were criticized in one of these early papers. There was a run on them around 2011. It's where a lot of people's of the mainstream scientists said, well, let's close the door on this one. In fact, they wrote a paper called a Requiem for the Younger Dryas Impact Hypothesis.
Yeah, I remember that.
Yeah. And there should never be a requiem for anything in science, for God's sakes, right? But they tried to slam the door. It has not worked. And we have published papers countering their claims. But back to what I was saying on this, they said that the carbon spherules was actually bug poop.
Oh, yeah, that's right.
And that, I think they call it sclerata or something like that. And that just stretches the imagination and challenges the integrity and credentials of the scientists who were looking at through a transmission electron microscope. They're going to be able to determine whether it was bug poop or not, right? And you're not going to go and publish bug shit and claim that it's carbon spherule. But the point why I'm bringing this up is that at these locations, the nanodiamonds were found in the carbon spherules. So in that phase transition of carbon down the spherules, some fraction of it went all the way to diamond.
Well, I'd love to know what kind of bug craps out
Sheds
diamonds. Yes, that's right.
Exactly.
Let's take another break, George. And
let's do it.
We'll come back to this. This is excellent. We'll
Thank you, fellas.
Yeah.
And we're back, ladies and gentlemen. The fourth segment of the show, and possibly not the last. We'll see. We want George to get through his whole slideshow and at least have one rant to be able.
You asked for it.
Yeah, we need the classic George Howard rant on the show at least once this time.
Well, it's so linear. It's hard to, I need like in my notes, rant. Slide 28, rant.
Yeah, that's a great idea.
God, I love to rant too. That's the most fun thing about public speaking when you get worked up into a good rant. And I had a couple of them out there in Sedona.
You did.
And see, I can't dance around on the stage. That was fun giving it stand up.
So wait a minute. Now that you've done the stand up presentation, now you don't really want to come on podcasts anymore, and you're making me sad, man.
Just going on the stage now, brother. Speaking of which, audience, I had the good fortune to hear the preview of the new album Procession coming from $50 Dynasty.
Yes.
And I tell you, folks, you kind of worry when you got friends that are multi-talented and they got, here they got a new talent. You're like, well, it just can't live up to the rest of their talents. And it lives up and it exceeds it. It is a fine album, man. It is a good, inspired music. And people are going to absolutely love it. What's the rollout time for that?
Well, I mean, I'm wanting to do the release on the solstice.
Beautiful.
So yeah, I think that gives me enough time.
So that'd be June 21st,
something like that. Yeah, should give us enough time to get all of our ducks in a row because we got a lot of work to do to get ready for that. But yeah,
you got a record player, George.
We are going to press vinyl.
I'm old enough.
We're going to make some vinyl.
I'll have to dig deep in the attic for that. But yeah, I'm 56. I had a record player. Damn right I did.
Yeah, it'll be a digital. It'll be a high quality digital release, but we're making vinyl for people who would like it as a record album.
Yeah,
that's the thing,
and
man.
it gives you a bigger canvas for the artwork too. So.
Yeah.
No, I thought it was just soulful music. Soul's probably not the right word because that has a particular connotation of music, but it was just. It was inspired and it just sounded good. And I'm no music expert, but I'm going to share with some of my friends. I've got a lot of friends who are big music folks, and I can't wait for them to hear it and say I actually know those guys.
All right,
they're going to
appreciate it, man. That's great.
Yeah, man.
Yeah, look forward on the solstice.
Mm-hmm. Procession.
That's right.
Are you using any of those newer songs in the cut in and out music?
Not on this particular show, but we will be.
Okay.
We're also going to be releasing instrumental versions of all those songs, so they will be available for use on podcasting and videos and all that kind of stuff. So we want content creators to be able to use the music.
Yeah.
We're going to do a Creative Commons style where they can, people can use it without.
We're still trying
working
to
on
figure
it.
out how exactly to do that publishing correctly so it works out. But
cool, man.
Creative Commons.
Maybe Johanna James could maybe use it too. I was in touch with her today and exchanged some emails, and she was so she hated missing Sedona, which would have been neat to have seen her there.
Yeah,
that'd have been another big YouTuber that could have come there, and we had some good YouTubers.
Yeah,
there.
We did. Yeah,
there was a lot.
Yeah, I mean, it's interesting. This thing was just a target of the digital environment. I mean, you had people in the audience who had larger followings than anyone on the stage.
That's right. Yeah.
I mean, how fucking cool is that, man?
That's right.
Yeah, it's just, really, really neat. And I think that can continue. She said she's not taking the jab yet, so she can't come in the U.S. or she would have been on some of the recent tours and stuff. So we can look forward to Johanna coming to the U.S. and that'll be really cool.
Yeah.
But back to maybe she can use some of y'all's music to go well with her stuff as well.
Yeah.
Okay, so we're showing you there that the diamond shitting insects were found at multiple sites across the U.S. because you're finding the nanodiamonds within the matrix of the carbon spherules itself, but then you also find it loose in the sediments at the sites that I'm showing. So you kind of got a arc of them from North Carolina up to the Northeast, across Canada and down south. And then you also find them in the sediment itself at Bull Creek. And I believe that's, excuse me, Blackwater Draw and a couple other sites there in the Southeast.
Now that's really interesting that these proxies are found so far north when that area, was covered in an ice sheet. So do you think these were maybe drained down through the ice and deposited there? Or is it possible that these were actual impact sites where the impactor came down and made it through the ice? I mean, how did they get...
that's one of those things I had explained to me so long ago. I can't remember the explanation, but it was satisfactory.
Yeah.
Because Lake Hind and Shabbat are known as Clovis sites. Right, that they're identified in situ undisturbed sites. So either just below it, that it bound, it curved up below there, or or they settled out there just afterwards. But I think that's actually a question too, because when you find a Clovis cache of any number of points that obviously was left there by somebody, and those have been found around the United States, you can assume that didn't experience a flood and wasn't disturbed.
Right. Yeah, and I guess before the Younger Dryas occurred, the ice had been in retreat for a long time. So it's possible that those sites were exposed. Then the Younger Dryas takes place. There's a deposition. There's a bunch of water, and then the ice moves down over top of those sites before it eventually retreats again. So maybe
that's where we need Alan here.
Yeah, maybe
Lake
they were protected somehow. Yeah.
So if somebody wanted to follow up on that and see what the conditions were at Lake Hind, but I need to brush up on that because it's an excellent question.
It is a good question. Yeah.
Yeah, you should have the answers, but yeah, there was an adequate explanation there, and it. I think somebody challenged our Lake Hind stuff in a paper. No, it was supported. That's right. A paper about 2 years ago was led by, was it Teller? One of the glaciologists up there. God, I don't mean to talk and not have my details at hand, but one of the eminent scientists up there has published in support of what we're finding.
Okay.
So yeah, you've got the nanodiamonds all over the country, but let's go back to the black mat, if you will, or the YDB layer, because you can see one there that doesn't show a black mat down on the bottom right. But what we're seeing here, folks, is just a selection of sites. There are many of these graphs. The way that you present this evidence in graphical form and for scientific publication is a graph that shows the abundance of various markers versus the depth at which they're found. And up at the top left, you see Murray Springs, which is a black mat. And then where do you find the abundance of the markers? Just below it.
Just below it, yeah.
That's right. You're finding magnetic spherules, magnetic grains, iridium in that case, although now platinum has become the more definitive marker and much less expensive to test and more reliable. And then you've got Shabbat, that's in Canada. So you actually do see a black mat there, and it says Clovis artifact found at that location below the black mat. And then you have Blackwater Draw and Topper, where you do not see a black mat. Although I think at other locations within the Topper site, you can see a change, but it's just not nearly as distinct. But at all of those locations, when you graph the abundance of the proxy materials from above the location 13,000 years ago to below it, you see a distinct peak right at that time. and oftentimes well above it or well below it, you see nothing. You see a little bit above, a little bit below, but that's because you have bioturbation and soil does mix. Mm-hmm. So it's not going to be totally exact. But when you look at it in graphs, it just jumps right out at you.
Yep.
And they did this for sites all around the world. I think I'm just showing 4 here.
Interesting there, though, at Blackwater, the magnetic grains do seem to start climbing back up close to the peak point. What's the year there?
As you go back in time.
As you go back in time. So that's interesting. And it could be, like you said, stirring of the soils. But, I wonder what that means. Very interesting. I hadn't noticed that when you gave this before, Yeah,
at Bull Creek in Oklahoma, you see another couple of peaks, like I said, in anti-diamonds.
Yeah, okay.
So, one good thing to remember, and I think I mentioned this in the talk, people got to remember that no one is looking at this stuff. No one does. This kind of forensic analysis in recent soils. They will go look in rock for it, right?
Right, because they're looking for
the Rise crater in Germany, or did the Chesapeake Bay impact, which is a great story on its own, 35 million years ago, et cetera. All of those proxies are found, but they're found in rock because it all had time to lithify. And this was so recent that this is soils.
Yeah.
The number of researchers that are looking for impact proxies in historic, you could call them, or modern soils is probably not much greater than the number of researchers on the Comet Research Group.
Okay.
And that's a damn shame, because the soils are available and the techniques are available, but the assumption is made that there's no reason to check for impacts in the recent past because they never happened during, the human experience to any degree that would be significant.
And most of this research is funded out of pocket by the researchers. Weren't you guys saying that? I mean, there is some public funding, people helping out as much as they can, but there's no like big grants, right? There's no university funding. It's out of pocket for a lot of these people. It's spare time and out of pocket. Yeah.
And that's an excellent segue to an appeal for funding.
It is.
And anybody that's interested, the Comet Research Group is what it is, to the extent it's formalized. It is formalized as a 501c3, as a tax-free deduction. And we receive very, significant funding through that on the scale that we're working at. It's very, very helpful.
Yeah.
And just like podcasts, that can actually start to support themselves because they have a dedicated base of listeners. The Comet Research Group at its Facebook page, you can find, and I'm not sure if y'all follow that, but Alan and I manage it, but Alan actively manages it.
Oh, okay.
And the Facebook page is pretty good. It's pretty good.
We're not on Facebook.
Yep.
Yeah, well, good for you. Good for you. But if you are, the Comet Research Group has regular updates there, and it has a very available link to the donation approach.
Okay, excellent.
Such that it is. Yeah, where you can send it. And Alan's very good. I donate money to it myself, and I'll actually pay for tests and send him, X dollars and say, yes, I'll help out on this platinum testing and whatnot. And he's very good about sending you the tax documents you need, to show that you've made those things. And that's tremendously helpful. And my gosh, if there were, just a Elon Musk or a Peter Thiel or any other enlightened human out there that I'd love to sit any of them down, but just happen to get wind of this stuff. We're ready to knock it out, $1 million, and you could prove this thing cold or perhaps prove we're dead wrong.
Right.
But the questions are worth answering.
So also at cometresearchgroup.org, there's a donate page. There's a PayPal button there.
I could put that in the show notes.
Dude, we need to sign up. They got monthly. We should become supporters. Over here. What the hell?
Just some of that snake cash.
Yeah.
Nah, I should have stressed that in Sedona. And
you did. You talked about it. You talked about it.
Yeah. Okay. Yeah. There's a way to give money, and it is tax deductible, which is always cool.
Yeah.
So you've got those very distinct peaks at these sites and all the others we've looked at. But the question is, we got 14 lines of evidence. We'll kind of breeze through those in a moment. And the question is, are they impact related, or is it just a normal rain of meteoritic debris? Because ablation spherules occur every time you have a shooting star. They're spherules that are resulting in that. Now, by the time they go from 50 miles high, and very occasional down to the earth, there's not going to be many of them in a given sample of sediment, but there's a constant input of very similar or identical materials that rain down on the earth, and we accept that. But when you compare the Younger Dryas boundary to the sediments which would have experienced the regular rain, you find here is, looking at this graph in a new slide, the magnetic spherules, for instance, are found at 13 of 15 sites, but they're 56,000 times as numerous as would be found in ordinary sediments. So it's pretty distinct. The magnetic grain, so when you see 0 on that earlier slide, it's really not 0. There's something there. You might not even be able to find it, but there's assumed, I won't call it crustal abundance, but that's what they would say in relation to the KT boundary of the dinosaurs, what the crustal abundance, but I guess you'd say sedimentary abundance. You can find magnetic spherules. In fact, you can find spherules produced through human activities, right? I guess you call that anthropic activities, that spherules are raining down all the time for the last 150 years because industrial activities create them. Smokestacks are shooting spherules that would blur this stuff tremendously. So the immediate sediments on the ground are chock full of spherules that are anthropomorphic and created by man. But then you go down and you can see 56,000 times as much of that as you hit the YD layer. For iridium, which is really now been replaced by platinum as the best indicator, it's 6,000 times as much iridium as might be expected. For carbon spherules, 18 out of 22 sites, 14,000 times as much as might be expected. And skipping over GLC, you've got nanodiamonds, 14 out of 14 sites, and 20,000 times as many nanodiamonds found at that key time as you would find above or below it. The distribution of the evidence, if I'd been on my game, I'd have fixed this slide up because it kind of has a heat map aspect of it, which we lost during some of the editing out in Sedona. But the point here is that the reason it became, fixed as part of the hypothesis, and also in people who follow this, their minds, they might say, well, why do we think it hit Canada? The abundance of the evidence, the abundance of the proxies becomes greater as you go towards Canada. So if you have a given site and you're looking for magnetic grains in X location, if Y location is closer to the ice sheet, you're going to find more of it.
Okay. Yeah.
And and I'm not sure this is the last word. This was kind of some early assumptions. I'm not sure how much work's been done on it since looking at that, but it was definitely evident in the early test results that the closer you got, the further north you went in North America and the United States and Canada, the greater the abundance of the materials was. So that suggests that there were air bursts and impacts in Canada in or over the Laurentide ice sheet. But let's switch to a whole nother kettle of fish after talking about the physical evidence. So we've been through the glass-like carbon, the geochemical evidence, the spherules, and the carbon spherules, both magnetic and carbon spherules. That's the physical evidence. Let's switch to kind of the narrative, and how does the current narrative of our past comport with this evidence, and how can we use this evidence to help resolve some of those mysteries that we defined early on in the presentation. And the most wonderful mystery of all is what happened to all the animals and why did some 250 species go extinct at or around this very time in history. And the current explanations for that have been argued about, I guess you could say, in dispute since the late 1960s, are the explanations being human overkill, that we hunted all of those animals to death, to extinction, to the very last one, climate change, that it was simply the climate, because again, it's well accepted that for the first explanation, overkill, that people hunted these animals. So they say they hunted them to extinction. It's well accepted that the climate changed. And that crowd says, which is kind of ascendant right now, that the climate change caused their extinctions. Both of them are true. We did kill the animals, no doubt about it, and we can cause extinctions, no doubt about that. And we know the climate changes, and that climate change can affect species. So those are two buckets. There's kind of a boutique explanation from Ross McPhee at the Natural History Museum in New York, that it was a pandemic. So that would have been the COVID of megafauna, a very effective COVID that drove them all to their disappearance.
But all those different species wouldn't have all been susceptible to the same disease. So that's kind of weird.
Yeah, would have had to have been very effective. That's what he's saying.
Very effective.
Very, very effective.
Yeah.
So, I don't ha-ha about that, because I ha-ha about human overkill. And we'll get to that in just a second. Yeah. But I think
it's an idea that should be
a good
explored,
contribution
right?
there.
Yeah.
Exactly.
Yeah.
Toss it out.
And he was dissatisfied. The McPhee and pandemic diseased animals. He was dissatisfied with the first two, overkill and climate change.
Yeah, right.
So that's not necessarily why he came up, but that's what led his, intellectual investigation to, there's got to be something else going on. And he came up with pandemic disease, and that has some adherence. But then we think, and I've seen this now in modern published books from the mainstream, that we're in the mix now. Not in every explanation or investigation of the various causes, but we're out there now, that the YD impact caused the extinction of those mammals. But let's look at the very first one, and that's the idea that the Clovis people hunted all of those animals to extinctions because animals had no fear of man. And I find that to be ideologically driven, if plausible, and it's plausible because humans are known to have caused extinctions. And I'm actually very involved in that dynamic in my business. And my company, Restoration Systems, is protecting the lesser prairie chicken in 4 states where it remains. And we're actually trying to save strongholds for those animals where the lesser prairie chicken can thrive.
Is there a greater prairie chicken?
Yeah, they're lousy with them. You find those in downtown Chicago.
Okay, so I was just making sure, because I heard lesser. I'm like, well, what?
Yeah.
The greater,
you know what?
The greater prairie chicken is doing fine. The lesser one is not.
You can't get rid of them.
Okay,
you cannot get rid of them.
Okay,
and but the lesser, he's a hurt. They're down to 22,622 birds. I'm joking a little bit, but it's down to 22,000. They've got them numbered, and it is just about to blink out. Okay. And we've got a good number of them on our chicken ranches out there that are going to be permanently protected and have developers of chicken habitat pay for that. But yeah, so we cause extinctions. There's no doubt about that. And it's one of the greatest shames of humanity. But could we have caused hundreds of extinctions and hunted them down with spear points, down to the very last one? And that's always the thing to think about, I mean, just hard to imagine people hunting the very last glyptodon down, and a glyptodon was a damn armadillo the size of a golf cart. And to this day, the hungriest man in armadillo territory does not eat an armadillo. Man will starve before man will eat an armadillo. Perhaps this is not time for a rant, but let me repeat. I would personally starve, and I am not big on starving, but I would personally start before I eat one of those little bastards, right? Nasty, damn armored little animal. Nobody eats armadillo, but we would have hunted them down to the very last one while there were still bison around, because bison made it. They changed.
That's a good point. And deer.
Rabbits.
Yep.
Rabbits made it. Deer made it. But somehow from Seattle to Miami to Tierra del Fuego, and the giant ground sloth. I mean, just think of the danger.
Yeah.
Of trying to get the last one of those and leaving a rabbit behind.
Right.
Why would you do it? So
and the Pleistocene lion, which was enormous. And there's so many
short-faced cave bear.
Yeah, the predator species is it's difficult to understand. I mean, how do you chase down and kill every last cat? Yeah, cats are sneaky and fast, and just I don't know. It just seems.
But it's ideologically convenient. And Paul Martin proposed the human overkill theory to widespread, acceptance and, self-loathing on the part of our culture in the 60s, that we had just discovered that, not just discovered, but we were just coming to accept and take responsibility for, to some degree, for extinctions, human caused extinctions. And then someone comes along and says, hey, I've solved the problem. We killed them all. As soon as we showed up, all these animals go extinct. And that's very ideologically convenient if you're trying to make a point about man.
Yeah.
But it doesn't pass the practicality test and the smell test, certainly in anyone that's a hunter.
Yeah, especially not since all of them went extinct at the same time. It would be one thing if like the mammoths went extinct first, and then the next one was the mastodons, and then sometime later, whatever, on and on and on. And finally,
you worked your way down to the last glyptodon.
Was the glyptodon, right? Yeah. But that's not what happens. They all seem to vanish at the same time.
Along with the people. That's the other hard part about it. It's like the people that hunted these animals to extinction, once their job was done, they went home.
Oh.
Right? They just disappeared.
It was aliens.
There you go.
The aliens came and did it. And then they also
needed another answer. And for people that can see the slide, that's answer number 4. Oh. But let's talk about those extinctions. So the idea would be that we enter the North American continent. The Clovis people did. Let's put aside pre-Clovis people because they don't show themselves as frequently. Certainly weren't as many of them, but they either came down the Pacific route, came through the ice-free corridor between the glacial sheets, or came down the Atlantic route. Really doesn't matter, but they encountered a virgin continent. And the idea would have been that they had never encountered man, so they would have been easy hunting.
Right, the animals had never encountered man.
That's right. And that would have been easy hunting. And we agree with that surely we had some effect on them. And the Clovis people were excellent hunters. But the question is, did they kill 5% of the animals or 100%?
Yeah.
And it just seems far more likely. Or did the impact happen and could be that we wiped out some of the last, right? And we had our big effect after the transition occurred. And obviously we're still here. And we'll talk about that in a minute, showing some point technologies that changed immediately at the YD. But that's the question. But one of the many ways you can kind of approach that in a skeptical manner is thinking about the Asian megafauna, because they went extinct too. And megafauna has been hunted there for millennia. And they're familiar with man, but they blinked out too. And that's true in Africa. They've been hunting elephants in Africa for thousands of years as well. And it's kind of an insult to them and the Siberians that somehow, well, not the Siberians in the case of the elephant, but there are places in the world we still interacted with very similar animals, but we haven't driven them to extinction. But in Asia, there's a little example slide where you've got the mammoth, the horse, and the bison, and you can see that they thrive. And then right around the YD, again, we're not talking that every single individual was vaporized in the impact, but the ecological change was so dramatic that very shortly afterwards, you don't find any more mammoth in Asia, with an exception of in the Wrangel Islands. The mammoth persisted up until 4,000 years ago. All right. So they were contemporaneous with the Egyptians, believe it or not. And that's called refugia. Those were little mammoths, or little tiny mammoths.
Okay. Refugia as in leftovers? Is that?
Refugia more like the hiding place.
Okay. Oh, okay.
You know,
a refuge. A refuge.
Yeah, refugia.
Okay.
Exactly.
All right.
And you can see the same thing with the horse here in Asia, that particular species, and also with bison. But when you go and plot where people lived with these animals, you find 202 dated mammoth sites in Siberia and Russia. And then let's look at where the people existed, where they found evidence of human occupation. It's all in association with the southern sites.
Right. So there's a bunch of mammoth sites that are way far north of where most people lived.
That's right.
Yeah.
That have been actually dated, and they know they were there, but there's, been enough investigation at that site, but absolutely no sign of human occupation, with one exception up in the kind of the northeast corner of Siberia. One location.
Right.
So one Clovis age site in extreme northern Siberia, yet animals went extinct there too. And that kind of stands to reason if you think about it. It's just, who the hell would go out on those islands and hunt down the last mammoth?
Right.
Yeah. Now, like I said, some did survive, and hell, that might even be Wrangel Island. But at one location are they known to survive much more recently than the time we're talking about. So what caused the extinction if there are no hunters in northern Russia and Siberia?
Right.
So humans likely contributed to the extinctions, but could we have been the only cause? Let's think about climate for a minute. The climate change theory, and I'd say that that's kind of the predominant theory now. Those proponents believe that as the Younger Dryas began, the return to near glacial temperatures killed the animals. And it was a pretty dramatic time, as you can see here from a slide showing the Younger Dryas temperature graphs. According to Greenland ice core data, it began 12,900 years ago. Temperatures dropped very, very suddenly. And you can only imagine the trauma it caused us, if temperatures dropped 10 C or 18 degrees Fahrenheit and stayed there for more than 1,000 years, it would certainly kill a lot of people. But in terms of animals, you got to keep in mind, animals migrate. That, if temperatures drop suddenly, you're going to cause a lot of habitat change and loss, but some of them are going to head south.
Right.
And you could find places in, the more temperate zones, or I guess you'd say tropical zones, in North America and Central America, et cetera, where they probably would have been able to migrate to. But really, if you think about it, this is the best counter to the climate change approach. I'm showing now a slide of the last 400,000 years of climate, which is just fascinating in itself, the Younger Dryas event notwithstanding, that they run in roughly 100,000 year cycles, where each ice age is followed by a long cooling followed by a brief warming. You can see the YD portion of the time scale on the far left, because this goes from more distant on time on the right to more recent on the left. That, there's a dip there, but there were no previous extinctions. And there are dips in there that are every bit as dramatic as the YD. So that's really something to think about in terms of, all of this, that if it had anything to do with climate, why would this particularly dramatic dip, and we agree it was the dramatic dip that was unparalleled, perhaps in the last 50,000 years or so, but why would that one cold period cause such a change in species composition when the previous dips, of which there were many, for hundreds of thousands of years before did not cause extinctions.
Right.
Yeah, it's
Very
The
much calls into
animals
question
managed to
climate.
survive those previous 3 extreme dips in temperature, but for whatever reason, we get to the Younger Dryas one, and then they all die. So it seems like that
It's the
climate
wasteland.
change. Yes, climate change can't
That's
be
right.
explanation.
Something else is going on.
Right.
Something else is going on.
Habitat loss.
Yeah. So we don't believe extinctions were caused by climate. So impact event is the cause. We don't believe it was the only factor in the extinctions, that surely there was climate, obviously caused by it. There was hunting. Perhaps we'd weakened them before. Perhaps we picked off some of the last ones. But it was, we believe, was a major cause. And that the effects that resulted in that extinction would have been massive explosions beyond our imagination. Only nuclear war can begin to compare. Intense firestorms, habitat destruction, and toxic chemicals. And Joanne Ballard on our team has done some work on that, and there's some pretty good chemical math that says that in this kind of turbulent environment that you'd end up with an acid rain condition.
Oh, yeah.
And there are actually some tusks that are eaten away below. It's a fascinating, if we wanted to break away from the PowerPoint, it'd be a good Google, but the tusk, you know how they have flaps of skin that reach down?
Yeah.
And they kind of cover the tusk? Right below where that flap of skin is, the tusk is just eaten away, right, by acid. So there very well could have been
and then that gets into the water.
Toxic.
It hurts the plants.
Absolutely.
Yeah.
Yeah. 300 years of spoiled water is going to kill any
species. It's going to kill everything. Yes, that's right.
Absolutely. Absolutely.
The tardigrades are taking over
as a result of impact. That's right. So explosions, firestorms, habitat loss, chemical atmosphere, and the dramatic climate change affected plants and animals. But let's talk about humans. Okay, this is kind of close to home. I'm in North Carolina. This is down in South Carolina. This is a distribution map of known Clovis finds. And you can see it's pretty widespread. And it has a certain character to it. You know, they're found across the state, concentrated around the Savannah River. But there was a lot of tool making then. And then you go from the Clovis type point to the redstone, the follow-up lithic technology, where they fairly dramatically change the nature of their tools. You find many fewer redstones than you find Clovis.
Right. So the distribution of Clovis sites in South Carolina, there's a lot more of them than the redstone sites, which are the people after the Younger Dryas.
That's right.
Yeah.
And you're assuming that's a proxy for population.
Right. That's right.
Or it would have to be
that
those
not a lot
redstones, you would have to use a lot fewer of them, and they only left them at certain locations.
Yeah, right. It's interesting too. Yeah. It's like, you can see the Savannah River site for the redstones, but there are not a lot of them on the coast. Interesting.
No.
It was too dangerous.
Yeah, that water was,
kept rising.
It'd have been 600 feet lower, right? So maybe the point concentrations on the coast are offshore.
Yes. For the Clovis, there should be point concentrations way out farther than we're seeing right here on this map.
That's right.
But it's just the redstones are not on their current coast. It's just interesting.
No, but that's right. But isn't it nice that it matches up, that you do find the area of highest abundance at that same location in central South Carolina?
Right, yeah.
That would have been it's like that would have been a safe zone, because the coast at the time of the redstones could have been changing quite rapidly.
Yeah.
So they're like, oh, we're not going to camp there because you never know when the sea's going to rise up more and bury the camp.
Right.
So many more Clovis points than you do find the follow-up technology of redstones. And then it's graphed in a different way. The ratio of Clovis to redstones is, you've got a hell of a lot, 8 times as many in Virginia, 5 times as many in South Carolina, 3 times as many in North Carolina.
So there were a lot more Clovis people than the redstone people is the implication here.
That's right. That's right. And, that had been little noted in the literature, but that's rock hard stuff. I mean, that's quantifiable stuff. You got to have an answer for that.
Right.
And it's interesting. This wasn't in the literature, and then we explained it. This was Al Goodyear learning of the catastrophe, joining the other science, being on the first paper. Then he went back and said, well, let me see if there's any indication that population dropped.
Yeah.
And
those arrowheads are
damn
beautiful.
if there wasn't. And that's what a good hypothesis should do. It should be predictive.
Right.
And indeed it was in this case. So in this data set, it indicates that human population declines 60 to 80%. Instantly. So it's a bad day for humans as well. But we're adaptable. So it makes sense that we could have struggled through where, your average giant ground sloth wouldn't have been as wily.
Right.
To figure out a way to make it.
Yeah, mammoths aren't going to be hiding in a cave, right?
Yeah, that's right. That's right. They've got no plan B.
Right.
Mammoths are really bad at plan B. So it's also true for Western point technology, which moves from Clovis to Folsom, right? And the Clovis people thrived immediately before this event, which is kind of strange in itself. But that's where you find the greatest number of them. And then as it transitions to Folsom, it drops off dramatically. You never find anywhere near as many Folsom sites, according to this survey, as you find immediately before the YD in Clovis points. And that suggests.
But is that showing us that there's at least one Clovis site that is dated at 10,300?
It does.
Yeah.
It does.
Interesting.
BP. That's right. But, dating squirrely.
Right. Yeah.
Maybe somebody was just hanging onto that old Magnavox TV.
Right. Yeah.
You had the flat screens, but they're always the holdouts. We still got them today. Still got the flip phone.
That's right.
But I'd guess that's just dating.
Right. Yeah.
But who knows?
But in general, what this is showing us is, again, there's a big abundance of Clovis sites right before the Younger Dryas. And then afterwards, there's a huge collapse. And then we see the Folsoms. Yeah. And a few Folsom sites before it. Interesting. Yeah.
So let's talk about the impact for here kind of in closing. What objects could have produced all the evidence but left no visible craters that we've identified or proven yet? No large impact rocks, the kind that you might find up in Winslow or at the Barringer crater, but left debris across 4 continents. Well, what does this thing look like? And this is important for people who follow this subject, God bless them. That, and our critics got it very wrong. I think their ignorance was kind of willful, particularly Mark Boslow's. But we proposed a fragmenting comet, that this was not a single point comet. This was not an intact, coherent comet. But this was a shower of debris from a progenitor comet, which had been breaking up in a process called hierarchical disintegration, where big pieces break into 2 smaller pieces, and you end up, and they do it at different speeds. It's not all together. And you end up with a whole mix of different sized objects, but many, many, many more small objects than large objects. So do we have any example of this in modern times? Have we witnessed this kind of process? And indeed we have. We've got several have identified it in several different comets, in modern times, particularly with the kind of the iconic one is called Schwarzmann-Wachmann 3b. And that was a 4-kilometer wide object that is now separated into a swarm of objects with still some, you can see there's a good photo. I know the people listening can't see it, but you see a shower of debris of different sizes with a large one still in the center and at the lead, and then a bunch of follow-on bits of varying sizes. And this is really important kind of in terms of future threat, that the first thing you got to remember is that we suppose this was a comet, and that helps you in a couple of ways. One, it helps explain things in a couple of ways, that an asteroid is going to be relatively rare. We've got the math pretty much down on that. You can reverse engineer asteroid frequency and figure how often does one, stray from the asteroid belt, and how often are we supposed to see that. And that's relatively rare, but it's actually more common than you would expect to find one coherent comet that slams into the Earth.
Yeah.
But we're not talking a coherent comet. The cross-sectional area the Earth crosses of a fragmenting comet is far, far, far larger than the discrete point of a coherent comet. And that's the way impact frequency estimates are performed now. Unless I have missed something. Yeah, other than the work of Klube, Napier, and their successors, the British neocatastrophists, as you call them, who've been screaming this for 40, 50 years, that quit doing the single point comet estimates, take some proportion of comets that turn into not rifle bullets, but shotgun blasts. And what are the odds of encountering a shotgun blast over a rifle bullet?
Yeah, much
Kyle,
greater.
I'll play Randall. Kyle,
Well, let's see. According to my
who's a better shot?
It's much more probable that we'll run into the shotgun
Much
blast.
more probable. Yeah, that's right. You've got the big swarm. This one hasn't broken up. You remember I said it's been 7,000 years. This one's been breaking up during our lifetimes. It's already, and this is kind of a dated slide, a third of the width of the U.S. And it's coming in again. On May 30th, there was recent news. Before the program started, y'all said y'all looked it up, but you didn't find any
we found a 2006 article talking about it, about a big breakup event. And then in that article, they were estimating that we might run into a dense part of the stream in May of 2022. But I wasn't able to find anything more recent than that.
Huh. I'm tempted to live Google that.
Do a live search.
Yeah.
Well, I tell you what. Let's take a break, and we'll come back, and we can talk about this more. One more break. We're going long.
Yeah, let's break it up.
Going long,
Thank you
folks.
for all the time.
Yeah, man.
I appreciate it.
We'll be right back.
Okay.
And we are back, ladies and gentlemen, Brothers of the Serpent podcast, segment 5, the mythical and magical segment 5, long show.
We should take this off and put it on the Patreon. Don't give those freebies access to this.
And we are joined by George, we're finishing up his presentation here, and we're looking at the fragmenting comet like Schwarzmann-Wachmann 3b, which will be impacting possibly at the end of May. And we will discuss that maybe in a future show. George was able to find some long articles about it, so I'll put some links in the show notes.
Yeah, May 30th. It looks like about 1 a.m.
All right.
So,
could be the end of the world, folks. You just never
it'd
know.
be cool as hell. I don't want end of the world, but cool as hell, I'll take.
Yeah, okay, yeah.
Yeah. Just not cool hell.
Right.
So yeah, Schwassman, Wattman, it's a modern example. And again, that's the, that's kind of one of the insightful things I think you can take away from this is just that idea that we calculate the frequency we would expect to encounter cometary objects in a pinpoint, not a shotgun blast.
Right.
But we have evidence that they're shotgun blasts in our own lifetimes. That's not rare. Most comets fragment, and they don't account for that.
So the comet nucleus, the head of the comet itself, might pass us by millions of miles, but we still run into the shotgun blast of the fragmentation.
That's right.
Yeah.
And as Bill Napier explained it to me, and now Graham's cribbed this, a couple others I think brought it up too, but I know I heard it firsthand. And Bill Napier's one of the people who gets this right, who originally introduced this kind of thinking, again, 30, 40 years ago, that it's not asteroids, it's comets, it's not regular comets, it's fragmenting comets. He says it's like that we walk across a busy highway. Well, no, we walk across a highway at a random time. If you did so and just walked across a highway at a random time with blindfold on, that, believe it or not, most of the time you're going to be just fine. You turn around and walk back. You're probably not, you might have some close calls, but you're not necessarily going to get hit. But there are periods of increased activity on that highway. And that's what we encounter. That's why it can go from a meteor shower that's periodic but not dangerous to sometimes you cross that same highway and it's not just infrequent cars, it's a whole bunch of cars and some very large trucks and some dump trucks.
Yeah.
And some doomsday fragments
in
there. But you're just not going to see it that often, and it could be seemingly random when you do until you have the full picture, which we haven't developed yet.
Yeah, we're just not really sure when the cosmic 5 o'clock traffic jam is.
That's right. Yeah.
That's right. But we must have some ability for them to say it May 30th. I just wonder how they got to that. But that's kind of beyond me. I'm going to try to do my best with this stuff, but I don't know it all. So just to summarize the impactor hypothesis, there have been numerous fragments of a comet from dust size, the kind you'll see in a regular meteor shower, to up to 2 kilometers wide. You would have had ice craters if it were concentrated in the north that would have left very little traditional crater evidence as we would think about it. Remember, a 2-mile, they're in a crater on Earth that's 2 miles deep, or not many. All right. And if you hit 2-mile deep ice, you're just not going to be left with anything. Then you would have had Tunguska-like airbursts. The vast majority of the objects would have been of a size that they wouldn't make it to the bottom of the atmosphere, but they would release all of their energy within the atmosphere itself. And that's a terrible, terrible, terrible explosion in itself. And that would have led to widespread canopy of fires across the Earth, intense continental firestorms, and high temperature shock waves ripping across the landscape. A very, very bad day or two for planet Earth. But there's more to come. We're developing additional data on this. And as you know, Alan West revealed that we found shock quartz at multiple sites now.
Oh, yeah.
And that's to be published soon. There's a killer new site that we're not sure is related to the YD, but it was a bad day at whenever. It's hard to date, apparently, in Louisiana, that's being dug as we speak. And, there's a significant amount going on behind the scenes with this at all times. Like for years, we had the Tell All a Mom story under development. And that's 6 years of just not even bringing that up because it hadn't been published yet. So you try to keep your mouth shut if you're on the, fortunate enough to know about some of the stuff under development. I promise you there's a lot more to come. And, pep the Cosmic Tusk a little bit. That's my website. Y'all know of it. Purpose of the Cosmic Tusk is because we had gone to presentations that have been treated so really poorly. I thought there needed to be another voice in this that kind of went after our critics, and that's not all of what it does. but it's a fair amount of it. And I've been on a post drought now. My apologies if anybody that follows the website's been interested, but I was good. I was week after week after week for about 4 months, and I've just fallen off in the last month or two.
Damn it.
And then,
Yeah.
I was looking for
someone,
I was like, I'm going to Tusk's website. I'm going
Right.
to find a response to this new dating of the Hiawatha crater, and he's going to be trashing them to the hilt. And then there was nothing.
There's nothing there.
I know. And Hiawatha, and even the first one I got a couple I got to do before I get to Hiawatha, like something on Sedona, just because I try to keep it conversational a little bit. Here's something that happened, So I don't know. And then there's some other subject out there that kind of that Hiawatha takes a back seat to. And we can talk some Hiawatha, but I just don't think the physical evidence matches up with a 54 million year old impact, or 56, whatever it was. And just real briefly, for those people who might know about the Hiawatha crater, the YD Comet Research Group never seized on that as evidence because you don't know where it's going to date to. And there was, you'd identified a crater based on the ice above it and the layers of that cake, which are much like the stratigraphy of soils, it gave every indication of being 13,000 years old. And a paper came out about 6 weeks ago that said they had tested, I think it was 2 bits of material that had emerged from beneath the ice cap, but on the crater. So it doesn't necessarily mean it's from the same impact, but that material was 54 million years old. And there's some, was it
58?
58.
58.
Yeah.
Well, the first place I go with that is the Chesapeake Bay crater, which is hell of a damn interesting geological site, but kind of still little known, that all of the rivers in Virginia take an eastward turn because of the trauma that I'm not sure if it's a coastline at the time, but that area on Earth went through 35 million years ago. And there is a tremendous but non-visible impact feature beneath the Chesapeake Bay. The Chesapeake Bay would not look as it does without there having been an impact 35 million years ago. But that crater is only identifiable by doing deep borings into the rock and showing where there is breccia and where there is not and whatnot. And that was all well done by USGS, by the United States Geological Survey, a guy named Wiley Pogue. And it's a great story in itself how Wiley Pogue came up with this hypothesis and then was able to get the funding to go prove there's tremendous impact. The reason I bring it up is you can't tell there was ever a crater there. And that was roughly half the time back to now the time that they give you for the Hiawatha crater. And the Hiawatha crater is as perfectly formed almost as the Barringer crater in Arizona.
Right.
And it's in the most dynamic environment on Earth with ice sheets moving back and forth, or, the grinding it for at least the last 500,000 years. Why would it still be so intact when other impacts virtually that old have already turned into rock and aren't visible at all?
Right.
Yeah.
Yeah.
Yeah, it would be I think Dr. Sweatman said if it is that old, it is by far the best preserved crater on Earth in known existence. Bar none, because it like you said, it's in a highly erosive environment under the ice, where there are other craters that aren't under ice that are completely invisible, that are half that age. So yeah.
And I believe it was Joe McGregor that was on the original team, and the original team gave many, many indications that they thought it dated to the Younger Dryas.
Yeah.
In fact, we heard on the grapevine, I have no idea whether this is actually true, but the grapevine said that they had some 20-some references to the Younger Dryas impact event in the original Hiawatha crater paper in Science magazine. And all of the references were struck by the reviewers. They had to completely disassociate themselves from what they believed to be the likely timing of it. And those associations with that timing came out with the reportage to their credit, by Science Magazine and NASA in their videos and collateral material explaining the new paper, both tied it to the Younger Dryas event because they know that cake pretty well. That ice has strata.
Yeah.
And they can read it pretty well. And that strata only dates back 13,000 years when the ice goes back 300,000. Right. They had only been collecting it.
So,
and there are other indications too. There's water at the bottom of it that suggests that there was some kind of remnant heat still around.
Yep.
And all it has to be is 33 degrees, and then you're going to get water at the bottom of it. And there were just a lot of things that indicated to those people who had no interest in getting in this crazy Younger Dryas to date. And then Joe McGregor, when he tweeted out the new paper and he was on it, said there's a lot more to learn, kind of ... that it just seemed to me he wasn't even convinced. So I'd like to reach out to that team and see whether you could get some of them to, give us the thing on it. But bottom line is, I think there was some fuckery there.
Yeah.
One way or another.
Yep.
The two little grains dated to 56 million years trumped your lying eyes.
Yeah, there you go.
For what's out there, because it would just be too traumatic to have to admit that we're dead fucking right about this shit and have been for 15 years.
There you go. That's right.
And you've been damn, yeah.
Have a rant, George.
Yeah. I never really got a full rant going, man. I'm in the office,
Oh yeah, that's true. But yeah, once the critics publish all these papers ridiculing the team, making fun of them, and having headlines like, what was
Requiem.
it? A cosmic disaster.
Yeah.
cosmic. Yeah.
The Younger Dryas Impact Hypothesis, a cosmic disaster.
Yeah.
Or whatever it was in that paper.
Mm-hmm.
Of course, they can't allow there to be a crater that dates to that period, right? Now, then they're the fools.
Yeah.
So you can see how people get embedded in their own preconceived ideas, and they don't want to let them go. It's like they've got too much riding on that line.
They sure did.
That's unfortunate.
They sure did.
So anyways, you got the bib here at the Cosmic Tusk.
Yeah, just going to close out last slides. Just if people are truly interested in, I know that people are truly interested, but if you get to the point where you want to read some of the original materials, Mark Young, good friend and collaborator I've never met in person in Adelaide, Australia, and I have assembled a bibliography that goes back to that first paper in 2007. Now, there's certainly other suggestive science going back to Plato himself, but we pick up at 2007 and provide every paper that had a direct relation to the developing science on the Younger Dryas impact. Then we do a little editorializing by categorizing them into supportive, ambiguous, refuting, et cetera, where they kind of are versus the hypothesis. And if you go and scroll through it, there are as many, well, they're actually, technically, there are more supportive papers than there are not. And so this is live science, and you can read it all there. And I'd encourage people, don't let scientific papers scare you. It was like when I was in college, whenever I'd see all the citations, it would just give me the chills for some reason. Just said, that's not for me. I can see the citations. They got all the little fine print at the bottom and all that. That's for scientists to read. But no, this stuff, even if you don't know every word, you could very well get the gist. And a lot of times you can see the fuckery from the other side, even if you don't understand everything they're saying. And frankly, one thing you'll notice is that our papers are far more detailed. That theirs generally, with very few exceptions, provide no field evidence. They're just throwing tomatoes. And then the critiques will be thin and generally not well composed. And then our evidence is extraordinarily well composed and will sometimes run for 100 or more pages of information and actual laboratory data. And then the critics then it shows up in the headline the same way. They never say in the critical paper, Younger Dryas team confuses bug poop, with carbon materials from an impact. They won't tell you the bug poop paper was like 4 pages long.
Yeah.
And then the investigation of the carbon spherules was, hundreds of hours with a TEM. And that the bug poop paper was using an optical microscope. And that's happened several times where the critics will use an optical microscope. This happened with Todd Serval's critique of the magnetic spherules, that he went and said, no, they aren't there. But hell, he wasn't characterizing them. First, he sorted it wrong, but then he didn't even use a transmission electron microscope, a TEM, which is the equivalent of talking astronomy and trying to refute another astronomer when you've got, a handheld eyeglass looking into space while the other person's using the Hubble telescope.
Yeah.
You've got to, have a similar forensic laboratory equipment ability as those you're critiquing. And we see time and time again, they don't go to that length. But this has been a lot of fun. I don't mean to drag it on.
No, that's good.
Yeah. No, I love the snakes.
Well, we love you, George.
Snakes.
Yeah.
Man, it's good stuff.
Thanks so
I'd
much.
like to get on and talk about some other weird shit.
Yeah. Yeah, we need to.
Yeah.
We'll have you back on. And you know what? I'm going to do this too. I need to add the Cosmic Tusk to the website as a.
Oh, thank you.
Yeah, just put a link.
Yeah.
I've got a page on there for YouTube channels and websites that are friend of the show. I need to put the Cosmic Tusk on there. I don't know why it's not on there already.
What the heck?
I know.
man?
Clearly I've been slacking
it's
on my
like-
job.
Shoot, I haven't put up an appeal for funding or at least a link to fund us on my own damn website. It's funny what you can leave off, some of the obvious things you can leave off a web presentation. You think it's all done. You're like, great, it's done.
It's done. Nope.
Yeah.
Yeah.
And you'll be missing some of the best stuff. So we all do that. And I just appreciate the time to be able to come on and, verbally share this stuff. The better days are ahead, gentlemen.
They are.
This thing only gets better and better.
When are you going to get out to Scablands or Montana, one of these trips with us?
This year.
Are you going to do it this year?
Lot closer than Egypt.
Oh, all right. Yeah.
I don't know if I do another Egypt with, although that'd be fun as hell with you guys. I'd consider it. I tell you, that Egypt takes a lot out of you, man.
It does.
I don't know. I'll see how other things go in my life. As you guys know from talking last week, we're empty nesters, my wife Pam and I now.
Yeah.
And that has made it a lot flexible, but it's been incredible how the parent visited LSU and the big game at Woodbury Forest School where my son goes happened to fall on the critical dates of some of these tours and trips where I can meet people. It's just uncanny.
Yeah.
I mean, if I hear there's a big date, for my kids, I'll immediately go look at this stuff. Say, that's when the good tour is. Or if I see a good tour, I'll say, hey, honey, there's something coming up on May 20th, right? And she go, oh yeah, that's
Yep.
that's when the great field trip was here. So, hopefully that cycle of bad luck will break.
Yes.
This
Excellent.
year.
Well,
you'll see more.
Yeah, we definitely look forward to more hanging out with you in person and doing some stuff out in the field. And we encourage anybody else, you want to meet George, you got to show up on these trips. George is a great guy. A lot of fun to hang out with.
I appreciate it, guys. We're going to have years of fun with this stuff.
That's right.
And as I say, it's only going to get better.
That's right. So everybody should check out CosmicTusk.com. That's it, right? That is CosmicTusk.com.
That's it. That's right.
Yeah, and you can...
And Twitter. And I'm real active on Twitter for better or worse. And that's George Howard at George Howard. Cosmic Tusk. You search Cosmic Tusk, should show you anything about this. There's no other use of that term in the English language.
That's right.
Yeah.
All right. And you guys can find us, brothersoftheserpent.com. Send us an email, brothersoftheserpent@gmail.com. Check out the website, though, for all the podcast related stuff. Join our pyramid scheme, which helps us with the podcast. You can do it through Patreon or PayPal. All those links are on the website. And this has been a long show, so we'll go ahead and end it now. Do we have any? You see one?
I can't tell if these are. We are having a meetup event.
That's right.
Right?
Yeah. Meetup for the 13th to the 15th of May. We're almost full, so if people are interested in signing up for that, you better do it quick.
Yeah. So we don't have any executive producers today, but people are coming to the meetup, and that's where they're.
Okay. Awesome. All right. Thanks, George, so much for being on the show. And thanks to all of you listeners out there. We love you guys.
Always have.
Always will.
Thank you, Russ and Kyle.
Yeah, man.
Good night,
Great
Adamu.
public service.
Get back to work.
Adios.